Hello friends, it's MoNaCo here. I'm trying to record this video for some time. It's my fourth or fifth try. Either way, I think I got it this time. Our first video in our bonding unit is about a little bit of a review and how energy interacts with chemical bonds. So I want you to understand why atoms bond together and how energy plays a role in creating and breaking those chemical bonds. We call those endothermic and exothermic processes. So those are our goals for you today, to understand those basic concepts. Let's get into our lead in here. Why? Why do atoms bond? Well, atoms bond to become more stable from an energy point of view. So lower energy is always more stable than high energy. They want to be chilled out and relaxed. So when bonds form or break, energy is always going to be involved. And since chemistry is a basic study of how and why energy and matter interact, of course we have to ask the question, how do atoms bond and how does energy play a role there? So I just want to show you a real quick picture of two atoms that are coming together. They were apart, high energy, and as they come together, they get happy, low energy. Okay. In this situation, here's a graph of how it came. The distance between the atoms, internuclear distance, as that increases, the amount of energy was higher. As the atoms got closer to each other, the energy drops, okay, here. And we get to the point where these two atoms are happy, nestled together and making a chemical bond. We call that the equilibrium bond length. That's a little advanced, but either way, here we go. Let's get into our review. So what's a compound? Remember, it's a substance that contains atoms of two or more different elements bonded together. We did particle diagrams of these things for like sodium chloride, and we picked one color for the sodium atom, one atom for the chlorine, and we showed them overlapping so that we had a chemical bond. That's how we showed elements connected in the first unit. A bond is a force of attraction between the protons, positively charged pieces, of one atom and the electrons, negatively charged pieces, of another atom. So it's like this force of attraction between the nucleus of one atom and the electrons of somebody else. Only the valence electrons, that's the outside shell, participate in chemical bonding. And bonds are formed as a result of a chemical reaction. So all chemical bonds are formed as a result of a chemical reaction at some point in the past. Law of conservation of energy and mass and charge relates to those chemical reactions, because during a chemical reaction, mass, energy, and charge cannot be created or destroyed. You have to account for all the little parts of a chemical reaction. You have to account for all your protons, neutrons, electrons, and protons have a positive charge, electrons have a negative charge, so there's your conservation of charge. Protons and neutrons have a mass, so there's your conservation of mass. And energy always makes the protons, neutrons, and electrons interact, so we have to account for that at the end of the day. All three must be conserved, cannot create or destroy them. The octet rule is related to how elements get to that magical 8 number of valence electrons around them. Noble gases already have their 8 electrons. That's why they don't react with anybody, generally speaking. Occasionally, you can get a noble gas to react, and you're looking at a periodic table. Krypton is possible to react. So is xenon. It's more metallic than the other ones above it, so it's more likely to lose electrons and more likely to react. An element that would likely to form a compound with krypton would be a nonmetal, so like oxygen or fluorine, because they're very reactive nonmetals. Energy in bonding is pretty straightforward. Spontaneous bonds are formed when energy is released and go from high energy for like the unhappy atoms apart by themselves to lower energy, happy atoms stuck together. Creating a bond allows the two atoms to have some sort of stability. Between the two of them, they have a pair of 8 electrons in their outside shell and they're stable. They follow the 8 is great rule. We call a spontaneous reaction where energy is released exothermic, and energy is a product in that reaction. I labeled the product side of my reaction here accordingly. This is a chemical reaction. Instead of an equal sign, we have an arrow. It can be like an equal sign because the products of mass, charge, and energy have to be conserved. So in a way, it's like an equal sign, but it's a special one for chemistry. Note how the energy is on the product side of the arrow because it's being produced or released. In this example, which is an exothermic example, we have to put the heat on the right-hand side of the reaction. Now, breaking bonds is not spontaneous. You have to consume some energy in order to do that. Because the compounds go from low energy, happy atoms, to higher energy, unhappy atoms. It's literally like running this picture in reverse. Low energy atoms getting torn apart, going to higher energy atoms. Okay, I'm going back to that picture. Essentially, ripping two atoms apart takes energy. It makes sense. Putting two atoms together produces energy. Tearing apart takes its energy. Okay, we call those endothermic reactions when energy is consumed, and we put it over the energy in the reactant side of the equation. Energy is on the reactant side of the arrow. In an ice pack, energy is consumed. What? The heat from your body is taken away from you when you use an ice pack to run the chemical reaction in the ice pack. The ice pack won't go unless it absorbs heat from the environment around it. So an ice pack is an endothermic type of reaction. So at this point, you should have a basic understanding of why atoms bond. It's to reach a state of lower potential energy. They want to get chilled out. And you should basically be able to describe how bonds form in terms of energy. Forming bonds releases energy, exothermic, it's a product of the reaction. And breaking bonds absorbs energy, endothermic, it's a reactant in the reaction. Your Easter egg for this video is to find two reactions, an exothermic reaction and an endothermic reaction, and write them on paper and bring them to me. Thank you very much for your time.